I'm Ty Roach, the lead for the Coral Reef Arks project. Coral reefs globally have suffered a devastating decline in overall health. Reef restoration efforts have centered around relocating nursery-reared corals back onto existing reef substrates. This technique typically has very low success rates and does not restore the ecosystem services which we need. One potential solution are what we call coral reef arks. These are large geodesic structures submerged and suspended into the midwater ocean. These floating coral reefs circumvent many of the problems associated with transplanting corals back onto the benthos, such as the lack of oxygen and sedimentation that are associated with degraded reef patches. Coral reef arks prototypes have been deployed in Curacao and Puerto Rico for 3 years. And our initial results show that 80% of the corals that have been transplanted to the arks are alive after this 3-year period, compared to only 42% of the corals on benthic control sites. Although we've had great success with these coral reef arks, there are still many unknowns. In particular, which materials would be best to make these arks, and which shapes and what hydrodynamic properties should the arks possess. Studying hydrodynamics in material science in situ in the ocean is not as easy as it might sound, as there's many complications with doing science underwater. In order to understand what needs to be done to improve these ark structures, our goal is to introduce coral reef arks into the Biosphere 2 ocean. It is a 2.6 million liter coral reef tank where we can precisely control the temperature, the wave frequency, and the current, allowing us to better understand the hydrodynamic properties of arks and to design new iterations of arks in a controlled environment. The Biosphere 2 also offers us the ability to monitor and measure these systems almost continuously. The coral reef arks not only serve as an innovative restoration technology, they also serve as a modular research unit which can be replicated around the world.